Hi, this is Stephen Fernandez, and let's go ahead with the 6 experimenting data structures called stack using linked list and queue using linked list. So it's in stack it will be just a normal operation of the stack, but through using linked list, and in queue it is also queue also requires only single pointer, and stack will require again the two pointers. So let's start by registering the files and creating a new node, like struct new node int info, creating a new pointer info, node star link, and in that struct node we will be pointing towards the head and initialize a value called data. So node star insert at empty and take the int data. So node star temp create a temporary node, temp is equal to new node, and temp arrow info is equal to data, and temp arrow link is equal to null because it is the first element, and then also put head is equal to temp because it is so it was an empty, it is empty, and this is the first element, and return head. So node at insert at the beginning. So at the beginning node star temp, and temp is equal to new node, and temp info is equal to data. So what if head is equal to null when it is empty and we are inserting it, also makes it as a first element in the stack. So temp arrow link is equal to null, head is equal to temp. Else temp arrow link is equal to head and head is equal to temp. Return head. Node star insert at the end, and this is a new function. Node star temp, and we also use a monk variable over here. Monk pointer. So monk is equal to head. When link temp is equal to new node, temp arrow info is equal to data. Temp arrow link will be null. So if head is equal to null, head is equal to temp. Because it might be the first element inside, and maybe the stack is empty. So while monk arrow link is not equal to null, that means there is some element inside that. So monk is equal to monk arrow link, and monk arrow link is equal to temp, and return the head function. So to display node star node pointer, create the monk pointer. So if head is equal to null, that means there is no element inside. Just print the list is empty. Else monk is equal to head, that means there is some element. So the elements in the list are, while monk is not equal to null, count monk arrow info, that means all the elements inside, and also with these will show that the first element as well as the arrow and showing the element, and then it will be linked towards, like it will be showing the first element, second arrow, second element, third element, and in the middle pointing towards the end. So node star delete, for deleting create this function node star temporary and monk two variables. While monk, if monk is equal to head, if head is equal to null, list is empty, we cannot delete anything. So else if head arrow info is equal to data, that means there is some elements inside. So temp is equal to head, and head is equal to head arrow link. So we have to convert temp head as temp, and then we have to delete temp. So and we'll return head. So the value of the head will be given to temp, and then we'll delete temp as that. Else while monk arrow link is not equal to null, so while it is not the last element. If monk arrow link arrow info equals to data, so if it is in the proceeding for the direction, so temp equals monk arrow link is equal to temp arrow link, delete temp, and then return the head function. Else monk is equal to monk arrow link, and print data doesn't exist. So inside the mains, we'll create this menu, insert element, beginning, insert at end, delete, display, exit, and we create a function called to enter the choice option. Then insert the option in the switch case, we'll take insert data, we call the data from insert at empty function, or the insert at beginning function will be called for entering in that. Insert at end will function will be called for entering at the end, and for deleting also the delete function will be called. For displaying, the display function will be called. Just to exit to exit, and this is an invalid entry because if the user puts a forbidden entry, that will just show that it is an invalid entry. So let's try. Let's try first. Insert at empty. Let's put 1. Insert at beginning. Insert at beginning. Let's try 3. And insert at end. Let's try 3 display. Yeah, so 3 145 is displaying. Let's try to delete it. Another 45. It is deleted. Let's display. Yeah, so issue the programs. Okay, fine. So let's go to the second program called queue using linked list. In this also, let's create the pointer variables, give the header files, and then int info node star link. Here we create these two pointers, front and rear. So we have to manage both of them. So in the beginning, front is equal to null and rear is equal to null. So int insert queue of data node star temp is equal to new node. If temp equals null, if temp is equal to null, that means the queue is full. Else temp arrow info is equal to data, temp arrow link is null. And if front is equal to null, front is equal to rear is equal to temp. So in case if it is the only element which we are adding, and front is equal to rear is equal to, so we have to manually bring front inside the queue and make it work. Else rear arrow link is equal to temp, rear is equal to temp. Else we don't have to mingle with the front, we have to just delete the rear. So in case of deletion of a queue, int data node star temp is equal to new node. If front is equal to null, it shows that the stack is empty, we cannot delete. And return. Else temp is equal to front, data is equal to front arrow info. Front is equal to front arrow info, delete temp. So we make front as temp, and then we replace front as temp, and then we delete the item inside the temp, and we leave front with the next variable, with the proceeding variable. So to display node star monk, if front is equal to null, count the stack is empty because the queue is empty. Else monk is equal to front while monk is not equal to null, and monk arrow info and uh, monk is not equal to null. That means it is the not in last element. There are other elements inside, so we have to go further and then delete it. So monk arrow info, monk is equal to monk arrow link, and then end it. So inside the main initialize data in choice while one inside the create this menu we like insert key delete to display, enter the choice, and also like inside the switch statement make it like insert a data and call this function. For inserting data, for deleting call this function, for displaying call this display function, and for exiting call the exit function. So let's try to run it. Insert queue, insert done, insert again, display, yeah. So I'll try to delete now. Yeah, let's display again. Yeah, so the program's working fine. Okay, okay.